Yo, 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 Math by the Moon here. Today I'm going to show you a little bit about simplifying powers of I, specifically with negative powers of I. So let me show you, first of all, what we started in our previous video, which were all the positive powers of I, okay, and build off of that so we can get into these negative powers of I. And what we found when we did these was that this pattern is a cycle of four things. After every four things, every one of these comes around and it starts over again. I, -1, -I1. I, -1, -I1. So since we're dealing with a cycle of four, we can divide the exponent by 4 and figure out where we fall. You know, are we at a remainder of 1? Are we at a remainder of 2? Are we at a remainder of 3 when we divide by 4? Or are we at no remainder at all? You know, if it's 4, if it's any power of 4, then it would just be a 1. So these four things are the answer to every single one of your questions. So what we have then is the ability to make a nice little pattern here. And I have them listed across the top. You might want to jot those down. I, -1, -I1. And underneath it, I'm going to write the remainders when divided by 4. So these are going to be our remainders when we divide by 4. If we divide by 4 and we get something with a 0.25 or a remainder of 1, it's an I. If we divide by 4, right, we're dividing by 4, divide the exponent by 4, and if we get a remainder of 1, it's an I. If we get a remainder of -1, it's because its remainder was 2. If we get a remainder of 3, the answer was -I. And if we have no remainder, if it's perfectly divisible by 4, the answer is a 1. Okay? So that means here what I'm going to do is I'm going to just take this exponent and I'm going to divide by 4 and see what I get. 24 divided by 4 is 6 evenly. I don't care that it's 6, but I do care that it would be no remainder. So that means I could write it out as a power of 4 over and over again 6 times, and that'd be just 1 times 1 times 1 times 1 times 1. So the answer to this is whatever this guy says. Since its remainder is 0, it's a 1. If I divide this by 4, divided by 4, boy, that's terrible. You're going to get like 80 and 1 left over. That means the remainder is 1. So we could have all these I to the fourths, 80 of them, and then just one little I left over, and all of those I to the fourths would turn into 1. 1 times whatever we get with a remainder of 1I would just be an I, since the remainder is 1. Again, I'm not really so much worried that it's 80 times, and that doesn't really matter to me. It's the fact that there's 1 I left over, and all 80 of those previous I's turn into 1s multiplied together. So I to the 47th, if we divide that by 4, let's see if we can get this a little quicker. That would be 11 with a remainder of 3. So I'm more concerned about the fact that it's remainder 3. So I come up here to my table, I look at remainder 3, and I know this would equal negative I. Okay? 54, if I divide that by 4, I get 54 divided by 4 will be a remainder of 2. So I know that I'm going to have a -1 for the answer to this. And again, all we're doing is taking the exponent, dividing by 4, finding what the remainder is. Not the answer, but the remainder. Okay, and that's going to tell us where we are in this sequence of I, -1, -I1. Now, let's go back and look at the negative powers of I. The first power of I we're going to do is I to the 0. It's not negative, but anything to the 0 power is 1. And that's probably a video for another time, but no big deal. You should remember that from Algebra 1 with your exponent properties. I to the -1 is equivalent to 1 over I. And I'm doing that based on our negative exponent rule from Algebra 1. Any negative exponent, move it to the denominator, and it becomes a positive exponent. In the next step, so we can figure out what this is going to equal, I'm going to change this to I to the, let's say, I to the 4th in the bottom. And if I change this to I to the fourth, I'm going to change this to I to the third. That way, this is still equivalent, right? And then I'm going to go ahead and I'm going to use what I know from over here. I to the third by substitution. I to the third equals negative I. And I to the fourth equals 1. So what I'm seeing here is that this would just equal negative I. So I to the negative 1 equals negative I. Okay? I squared, I'm going to do the same kind of idea here. 1 over I squared would be what I to the negative 2 looks like. That's going to be 1 over, oops, excuse me, not 1. We're going to make that I squared right here over I to the fourth. And we're just kind of temporarily borrowing some of these things that we already know the answers to so that we're still staying equal. You know, we have 2 more i's in the bottom than we do on top. So technically we're changing the fraction for a convenient reason so we can come up with a different answer. I to the fourth is 1. I squared is negative 1. So this would equal negative 1. So I to the negative 2 equals negative 1. I cubed, I to the negative 3. So we have, well, let's stick with 1 over I cubed. And let's figure out a way to make this happen. Well, I cubed would be the same as 1 over negative I, right? And so I'm just replacing the I cubed with the negative I. Now, what I want is I basically want 1 more in the top. So I'm going to make this I to the fourth over I cubed, and I still have that negative sign in front. All right, now we're ready to do a substitution. I cubed is negative I. And I to the fourth is 1, but it's got a negative in front of it, so it's a negative 1. And a negative divided by a negative is a positive I. Okay, so the last one is really quick, 1 over I to the fourth, and we already know I to the fourth is 1, so that is a 1 no matter what. Now, if I just look critically at this sequence right here, here was my original set of 4, right? I, negative 1, negative I, 1. And then if I try to pair these up right here, you can see how I to the first and I to the negative 1 are no longer the same, right? I to the first and I to the negative 1 are no longer the same. I squared is still negative 1. Even if it's a negative exponent of 2, it's still the same thing. I squared and I to the negative 2 are equivalent. I to the third was a negative I, but it's now a positive I. Okay, so what I'm noticing is that the only things that have changed now are the power of 1 and the power of 3. Okay, so the power of 3 and the power of negative 1, these have kind of reversed their answer. So let's go to some examples now that we have this and see how it impacts our work. Take these 4 things and write them down, and then right before it, let's write them down again. I, negative 1, negative I, and 1, okay? And what I know, I'm going to put a line right here for right now. I know that this was a remainder of 1, a remainder of 2, a remainder of 3, and a remainder of 4. I, negative 1, negative I, 1, okay? I know that this is now the same as what this one was, right? This was really not a remainder of 4, but actually 0, yeah? This would now be negative 1. if I just kind of counting backwards, right? This would be -2, and this would be -3. So these are our remainders. So what I tell kids a lot of times is, I want you to write at the top of your paper, I, -1, -I1. Then write it again, I, -1, -I1. And then start writing in your remainders. So you know you could start it, you know that 0 is 1, right? You know that. And then it goes 1, 2, 3, or 0 again, right? And -1, -2, -3. So if you can remember I, -1, -I1, and that anything to the 0 power is 1, you'll be able to get this really simply, okay? And now you can see how it's all kind of together here. The remainder of 1 is I when it's a positive. This is for your positive side. And when it's negative, remainder of 1, it's a negative I. So let's put this into play. Divide that by 4, you get no remainder. So it's going to be a 1. Divide that by 4, it's going to be 80 and 1 left over. So it's a remainder of 1, but it's negative. So it's going to be negative I, because it's a remainder of -1, right? -321 divided by 4 equals, who the heck cares, it's 80, but it's a remainder of 1, right? And it's a negative number, so we're looking at the left side of our table, okay, over here. So we're using the negative rules. Here, if we divide this by 4, we're going to get 11, remainder 3. And since it's a -47, we're going to come over here and we're going to find our -3 remainder, and that's an I. Okay? This is a remainder of 2, no matter how you do it. It doesn't matter. It's going to be -1, no matter what. So, if you can remember I, -1, -I1, I, -1, -I1, and then put your remainders across there, starting where the 1 is, kind of in the middle, right? 1 is 0. Anything to the 0 power is 1 anyhow, right? So that one has to be right here. This one has to be your sort of starting point. Count up and count back, and you can create your little powers of I cheat sheet, okay? I, -1, -I1. Say it to yourself a couple times. Make sure that you write it down twice and get good at making this little cheat sheet, and you should be good to go for any type of power of I, positive or negative. Let me know if you need any help.